All right, everyone, can we give Mr. Alok Mishra, Business Lead, Power Grid Asia Pacific DNV, a huge round of applause. Thank you so much, sir, for joining us today. The topic is going to be offshore wind grid integration, tracking key challenges for a resilient energy future.
Good afternoon. I'm Alok Mishra from DNV, and I'm going to talk about one of the latest and hot topic which we all are moving ahead with the new technology called offshore wind. So when we talk about the any generation, power generation plant, in any way, either renewable, non-renewable, thermal, one of the major aspects is the grid. Because grid is the ultimate truth of the any power plant, and that is going to be the backbone for the any power plant. As much as grid is a strong, power plant going to be sustained. So before moving to ahead our topic, I would like to just explain about little bit about DNV. So DNV almost 160 years, this 150 years, bit old one, but now we are celebrating this year 160 years. We have run in more than 100 plus countries across the globe, and as a DNV, we used to spend our 5% revenue in the R&D across the multi-industry project, where we try to solve the problem related to industries and make something for the humankind. This is more specific to our power system, where one of the world's largest hydrogen fuel estate testing lab we have based out of UK. When we talk about the entire power system, DNB can be part of the generation in the transmission, distributor, and also now all consumer converted to the pro-consumer nowadays. So we can help the industry throughout the value chain, including the system of operation, new technology like smart grid, data communication, and all data related. This is the small portfolio about DNB related to the power grid. We are in the power system planning related activity, where we do all type of power system study, including the grid connection study, which is required for the industry and for the CA and regulatory body. In the T&D, transmission and distribution sector, we have do all the technical feasibility related study, including the ERS system, and also like independent technical review, power failure investigation, and all. We have the asset management, where we do the SF life cycle assessment of the transmission and distribution. In fact, last year we released our first asset management roadmap for the DISCOM last year. We also, in the SCADA and digital system, where we talk about the cyber security, smart grid, and other new technology. This is covered by the entire energy market study, where we do the policy and regulatory related study. So now I'm moving towards the offshore wind. When we talk about the offshore wind, the DNV, as mentioned, we celebrating our 160 years this year. So what we make special in the offshore wind, that DNV has started from the shipping almost 155 years back. When we talk about the electrical engineering, we have started almost 100 years now. We are working with the oil and gas for more than 150 years. And when we talk about the onshore, which is almost 35 years plus across the globe. And when we talk about the offshore wind, these are the four major components and four major pillars. We talk the backbone for the offshore wind. So as we have the expertise, this all together, we make stronger in the offshore wind sector. When we talk about the offshore wind plant, there is a 5 pillar. First is the feasibility. Like any project, when we talk, feasibility is one of the important aspects, where before commissioning we do the market intelligence, like how market is strong, how markets are ready to adopt the new technology. Another, what would be my price, selling price, and other technology readiness level in the particular country, a particular aspect, who are the guy who can give the power to us, and who are the guy who can give product to us, like of turbine and other things. When we talk about the development phase is the one who will be do the, I would say, rough abstract of the product on the paper, and it is do the complete technically review and technically aspects of the wind farm. And when this technical abstract is ready on the paper, then it go to the engineering, where we do much more deeper thing, and we do the, basically we made the SLD, single line diagram, and other things related to the project. And when engineering is done, then we move to the construction, which is really site work. And once everything is constructed, then we move to the operation, where it will go for 20, 25 years. When we talk about the offshore and DNV, so we are everywhere which is required throughout these 5 phases. So when we talked about the life cycle, we can help from the strategy to feasibility to the operation, and also if any diagnosis or anything required throughout the value chain, we can help. Now I'm talking about the standard and recommendation process, because when we go for any product development, we always try to follow some rule, regulation, and some guideline. So it is easy for us to set the standards for them. And when we talk about the DNV, we are almost everywhere, and still industries used to follow the DNV standard guideline across the all major aspects, like transportation and installation of offshore wind turbine. When we talk about the ground connection, structure of the wind turbine, electrical installation of the wind turbine, offshore substation, manufacturing and commissioning of the offshore substation, everywhere generally still DNV guideline used to follow. And if you are interested to any guideline, you can follow this link, and you get this. Here I'm it is at a more specific, where we see if you related to the offshore standard, these all guidelines are readily available on DNB website. This is related to offshore, and also we did a lot of joint industry project where we talk about the means what are the major failure happened during some of the offshore wind experience, and we try to sort it out those in our GIP, joint industry project. When we talk about the development of offshore, the concept option, so these are the basic layout of the wind farm connection from onshore to the offshore to the onshore, where wind turbine initially connected to the internal cable array, which is generally about 33 kV, 66 kV. Now 132 is also coming in the prestige, but still not very mature technology. So generally, when we talk about this internal array cables, it is connected to the 66 kV. From offshore substation to is connected to the export cable, which go to the onshore substation, which is generally 220 kV to which is generally 220 kV to go up to 400 kV, yeah, based on the different grid requirement. And then it go to the transmission line, and then further it go to the consumer. When if we try to see on the a 3D image. These are the 3D image how any offshore wind farm is connected. So typically, if it is near to the shore, which is within 100 kilometers, we go for the AC connection, and AC connection go up to 700 megawatt to 20 kV, and the cable array generally it is 33 kV, so 66 kV. But when it is go beyond 100, generally and technically most ideal would be that go for SVDC, which go up to 2 gigawatt. And depend on our configuration and depend upon the capacity, go with and without 80 collector platform. And as usual, the cable array is 66 kV. This is a high-level comparison transmission capacity voltage cable length, and it's also defined the how much megawatt can we carry, and it should be HVDC or HVAC, like this blue line, and yellow line is talking about the HVDC. But these three, like red, blue, and green, in showing the basically the straight line showing the DC system, and the line with coming down to the SSC is showing the SC. And this is as per the SIGRE working group B140. When we talk about the Indian system, because already government of India coming from the new tender offshore connection, so this is how they are want to be connect the offshore wind to the system. And as per the government of India, until the substation offshore block, it is the scope of developer, and from offshore substation to the pooling substation, it is the scope of PGCIL, yeah, CTU. So this is the electrical infrastructure where depend upon the time given when we how technology change, and when we talk about the addition technology, HVDC going become the cheaper and cheaper. However, the capacity must be need to access for that. This is a summary of the connection technology, like medium voltage AC, HVAC, and HVDC. So when we talk about the capital cost, obviously HVDC is the highest one here. But when we talk about the losses, MVSC would be the highest one. The typical range, which is very important for us, when we talk about 0 to 20 kilometers, MVSC, like 220 kV would be the ideal. When we talk about 20 to 80, yeah, 100, HVSC, like 400 kV would be the ideal. And we go for HVDC, which is beyond 80 kilometers. When we do the basis planning of the offshore wind, our basis would be the how many number of turbine we have and which technology readily available. Because one of the major aspects when we talk about the offshore wind is the cable, and cable is really very challenging. At presently, our internal experience show that if you did the order today to the cable, it will be dead delivery by after 5 years, not within that, if everything go well. So one of the major aspects you have to be considered, that is the cable. And then number of point connection and other things. This is the different type of grid connection point. But as we are in the initial phase, so we are going to be the independent first one, where radial connection, like one substation wind farm going to connect to the one point of connection, like one substation. This is the three-core cable configuration for 400 megawatt. These are the HVDC, which is not much relevant at present for us. Now this is a typical layout of the any offshore substation, which is depend upon here. It is how it look like. So these are the array cable and these are the RSI, GIS, all things are connected, and also for the backup diesel generator is there. So I'm just touching about the SVDC. So SVDC for offshore, yeah, it is still very costly, but the way technology changing, it's really helping here. And these are the depend upon the maximum capacity, but I think still we have too long way to go for that. These are the different topology for the SVDC substation. Also, recently we released a report on the generation of hydrogen from the offshore wind, and in the RE Invest we released the report. So this is from my side. Thank you.
Just a moment, we are getting a mic.
Please, just I have a general question as a query. What is the specific value-added difference between DNV wind energy system compared to other existing international wind energy systems? What is the specific in DNV?
Sir, could you repeat your question once again?
Just what is the specific value added difference between DNV wind energy system, means your system, compared to the other existing international wind energy systems?
Sir, basically DNV is a consultancy on the renewable sector, and one of the additional part with DNP, yeah, I think which is given the upper hand is that our experience. We have the legacy of 160 years, and we are moving, working across the globe. So like we our expert working in Europe, who like offshore wind, he work in the Europe, they know what are the best things, what are the best things happen during the project execution. And when we are working the same thing in India, we can bring those experience here. Like similar way, they work in the USA market. And when we something learn from the USA market, when we come to the Europe market, we can bring those things there. And also depend upon the adaptability, because any technology has the different role in the different market. We can't go copy paste from one technology directly to copy. So what would be that technology would be localized in Indian market, yeah, any particular market, we have the better understanding, which give the additional benefit.
Just I want in terms of the value added, means how you are trying to make it cheaper compared to international markets. So I need in terms of value added, specific. If it is there, otherwise your presentation is excellent, sir. Please.
Sir,
Specific value added difference.
sir, these are the value added.
No problem. Thank you, sir. Please.
Yeah, good afternoon, sir. I think very nicely put up. My name is Commander Sinha.
Yes, sir.
I'm heading wind for Adani Green.
Okay, sir.
And I would like to just request you to give a slight insight into, you said about the cables being the biggest challenge.
Yes, sir.
What about the operation and the maintenance part when we have to maybe look for a transformer replacement, or maybe the main bearing or the gearbox? Second part regarding the blades.
Sorry, sir?
How are we looking at those aspects? Do we have certain specific case studies with DNV or all across global scenarios which can become applicable for this transition in the Indian renewable energy sector? Thank you.
Sir, you are talking for the onshore or offshore?
I said about the offshore.
Offshore, okay, sir. Sir, I didn't touch much about the Wyndham, but yeah, you really bring the very exciting thing, because the project construction it takes for 4 to 5 years. Let's suppose that from first phase to. But when we talk about the operation, it really moves for 20 to 25 years because whoever be building the asset, he does thinking about 20 to 25 years. And for offshore, we are completely new. So for the providing the training, because the best way to bring that, bring the knowledge within our engineer, within our society, to give a specific training to them. So there is two ways to give the training and give the technology adoption to them. First, either you share some of the best practices, let them visit and let them understand, yeah, work closely with the expert. Second thing about that, fit the new, some of the guy who had really working experience, who know what are the bad experience with the things, what are the good experience with, that can be the help to the provider training on the O&M. And regarding this, all the transformer and other things, yeah, this is the very challenging with the offshore substation. And because of, but this can be avoided, yes, when you have to go with the rigorous process to selecting your equipment, like transformer. That is one of the heart of the complete power plant. Either it is onshore platform or offshore platform. So you have to be go very rigorous when you meeting your specification. You have to be consider all the aspects which require that particular condition. Like I'm taking an example, we have two things here. One is the Tamil Nadu and one is the Gujarat. Two ideal potential sites for us. We can't copy paste from Gujarat to the Tamil Nadu, neither copy paste the same specification from Tamil Nadu to Gujarat, because the geographical climate condition is completely different both of the states. So when we talking, meeting the specification of all the equipment, we have to be very specific about each and every equipment. And based on the one of the major, yes, electrical is obviously there. I'm not denying the electrical aspect. But also the geographical condition, installation condition, and how we are going to do the complete, because when we talking about the failure, most of the failure only happen because of bad installation, yeah, with some of the things we missed during the installation. So first of the specification about the product, and second, you have to be very thorough process for the installation. And that must be followed throughout the process. If we take your initial phase, I think that should be given relaxation during the operation. However, yes, failure can happen after getting all the things. So those aspects, it is very challenging for us, and that's for that we have to go again with the same process.